Hi, welcome to the channel. I'm Mrs. R. Let's do some math. Hi there. Today we're talking about mixture problems. Now these are word problems that take a lot of analysis to make sure you understand what is actually happening in the problem. So I have my handy dandy favorite Desmos calculator here to stop us from getting bogged down in the calculation so we can focus on the sense making. So here is a typical kind of mixture problem. We have 9 pounds of mixed nuts containing 55% peanuts. We're mixing that with 6 pounds of another kind of mixed nuts that contain 40% peanuts. What percent of the new mixture is peanuts? We've got two different things that we're mixing together. Now in some of these problems, as they get more complicated, you might have 3 things or 4 things. But it does help if you kind of isolate the different things. So here's one package of mixed nuts. We bought a bag that says on the label 55% peanuts. And we're going to mix that with a different bag, 6-pound bag, that contains 40% peanuts. Now we want to know this new mixture, what percentage of that is peanuts. Now, there are lots of different ways to approach these, and if you're in an algebra class right now and your teacher gave you a formula or something, obviously feel free to practice with that and see how that applies and compares to what I'm doing. I do more of a sense-making type of thing. It's not just one formula, it's a whole process. But basically, I look at each of these bags first on their own. So that first bag, the 9-pound bag, has 55% peanuts. So my first question is, how many pounds of peanuts are in that 9-pound bag? If you think back to how to do percentage problems, we're looking at 55% of 9 is what? How many pounds of this mix is actually peanuts? So I'll do 0.55 times 9. And I get 4.95. So that's 4.95 pounds of peanuts. Now that's in that first bag. In the second bag, same idea, but this time it's 40% and the bag is only 6 pounds. So I need to know 40% of these 6 pounds, how many of those pounds are peanuts? So same idea. We're going to convert and multiply. And 2.4 pounds of peanuts. So then when we combine these two bags, there's 2 things to think about. What is our total and how much of that is peanuts? Because we want to know what percent of the new mixture. So our final answer, we're going to have total peanuts over total nuts in general, and we're going to change that to then a percentage. So our total pounds of peanuts, that's going to be the 4.95 plus the 2.4. That's the pounds of peanuts we got from each of those bags. And then the total nuts, we had a 9-pound bag and we had a 6-pound bag. So 4.95 plus 2.4, we get 7.35. And then the 9 plus 6 is 15. So to get this into a decimal so that we can get it into a percentage, because they asked what percent, we'll divide that out, 0.49, which then would convert to 49%. Peanuts. So that's my method on these mixture problems. I kind of find what pieces am I looking at and then mix together into the total. And if that process works for you, that's fantastic. We're going to do one more example using that process, and we'll just see how that goes. So we're going to clear out this page and start our next story. All right, here's our next mixture problem. How many milligrams of a metal containing 45% nickel must be mixed with 6 milligrams of pure nickel to form an alloy containing 78% nickel? Now, this is almost like a weighted average problem. So if you have strategies already in your back pocket for weighted averages, you could use that here. But I'm going to approach this in a very similar way to the last problem. Now, the question's set up very differently. Before, we had our two different bags of substances, and we wanted to know about the makeup of the mixture. Here, we already know what we want the mixture to look like. We want the mixture to be 78% nickel. Now, we have the pure nickel that we're mixing, and we have some other alloy metal that has 45% nickel. And our big question is, how much of that other metal do we need to mix with the pure nickel? We do have weights and measurements, right? So I know we want 78% nickel at the end. In this pure nickel, we know 100% of our 6 milligrams of the metal are nickel. 100%. So we actually have 6 milligrams of nickel in that one. The other metal, we know it's 45% nickel. So we do 0.45 times however much we have. And that gets us a certain amount of nickel. Some milligrams of nickel. We don't know how much of this metal we're starting with, so we don't know how many milligrams of nickel we actually have. But we know those need to combine to become 78% of whatever our total is, to be however many milligrams of nickel. So there's a lot we don't know here. We actually put a variable in for one of them. We put some blanks in for others. But I want to focus right now on this right here, because that's our actual mixture, right? So we have 100% of this 6 milligrams going into this mixture. So I know there are 6 milligrams going into this mixture. Then we're going to add 45% of whatever the other one is, right? 45% of X, right? That's going to get us, that will result us in a mixture that is 78%. So 78% of the total is going to be nickel. So we're kind of just focusing on that left-hand side and combining the first two individuals to get the last one. Now, when I said total, though, right here, when I said total, that would be the total weight of the metals, right? We started with 6 milligrams. We added however much this is. That gets us our total, right? So if I just put that in there like that, the 6 milligrams plus the X, we don't know how much metal that is yet, but it at least gets us referencing something. It gets us into an equation. We do only have one variable now instead of my little chart that had things all over the place. We are a little more structured here, and that's the beauty of algebra, is that it lets us take these kind of abstract ideas and structure it in a way so that we can just use some numbers and easily start to work with this. So just to rewrite as we're working this, 6 plus 0.45x equals, now let's go ahead and distribute this. So 0.78 times 6 is 4.68 plus 0.78x. Now we really just have a multi-step equation here. We've got some constant numbers. So let's go ahead and handle those first. So 6 minus 4.68, that'll be 1.32. Then we have our variable terms, so I'm going to subtract 0.45 x. We're left with 1.32 over there on the left, and we're going to subtract that, get 0.33x. And then we'll divide. 1.32 divided by 0.33. And doesn't that come out nicely? 4. So back in context, that means that 4 is the milligrams of the metal containing 45% nickel. So this would be 4 milligrams of 45% alloy is what we would add to the 6 milligrams. And now this was kind of a more complicated one to put together, so you might not be very confident. There might come a time when you are not confident in your process getting you to the right answer. So remember, you can always check your answer using that kind of more straightforward process we did in the first example, right? So we knew 100% of the original 6 milligrams was going in. Now if we're saying 45% of this 4, so we've got a 6 plus 4, 10 total milligrams, right? Now that 6 that's 6 milligrams of nickel. 45% of 4, how much nickel is that? 1.8. Add those together, 7.8 milligrams of nickel. And then just to double check, 7.8 out of 10, that gets us our 78% that we were looking for right there. So even when you have a kind of convoluted setup or you're not sure if you set it up right, remember you can always check your answers. See if the answer you got makes sense back in the problem. And if it does, if everything works out, then you're great. You're done. You can move to the next one. If it doesn't, then figure out how to rework the problem, how to do something similar. But there's the idea of doing these mixture problems. And if you thought this video was helpful, please hit that like button. It helps us make more videos. If you still have questions or you want to see a different piece of algebra content or math content in general in one of these videos, leave a comment, let me know. But ultimately, I'm Mrs. R, and this has been Me Doing Math. Have a great day, and I'll see you next time.